our very first and last episode of our first and last YouTube channel, the Chemist Queens. I'm Valeria and I'm here with Leslie and Michael. So today, in honor of our first episode, we're talking about makeup, also known as cosmetic chemistry. That's right, ladies. So take out your favorite products and let's learn a little bit more about what the process is and what it goes into making your products. So when you get up in the morning, you want to look like Beyonce, not a rat. Am I right? Yeah. So in cosmetic chemistry, there are many parts to creating the perfect product, but we are only focusing on 5, and that is pH, balancing equations, chemical reactions, surfactants, and polarity. So let's go to Michael and see what she has to say about pH. Take it away.
Hello, ladies and gentlemen. This is Michael, and today I'll be discussing pH. So pH is a measurement of the hydrogen ion concentration in a solution. So the scale goes from 0 to 14. 0 is very basic and 14 very acidic. And 7 is neutral. Water will be considered a 7, and it's in the middle. And low H plus is high pH, and high H plus is low pH. So if it's high, it's really low, and if it's low, it's really high. And pH plays an important factor in cosmetic chemistry because the product cannot be too acidic or too basic or irritate the skin, make it flaky or rashy. I myself had actually really bad acne, so when I use products that are very acidic, they tend to, like, if I drink soda maybe, it'll break my face out so bad. Maybe because it's like too much acid.
Balancing equations is making the reactants in the product have an equivalent number of substances. It's important to balance chemical equations because there must be an equal number of atoms on both sides of the equation to follow the law of conservation of mass. Mass cannot be created or destroyed. In many substances, it's essential that the chemical equation is balanced. It's pretty obvious why balancing equations is a very important factor in cosmetics. It finds the perfect balance necessary for creating the prime mixture of ingredients to make the makeup. Balancing equations is also essential for chemical reactions.
In case you are wondering, a chemical reaction is when one or more substances changes into one or more new substances. So there are 2 types of chemical reactions, and that is a chemical change and a physical change. So a physical change is when a substance changes shape or form. For example, water to ice. In a chemical change, there are 4 ways to tell if a change has occurred, and that is change in color, temperature, production of gas, and formation of a precipitate. For example, mixing water and food coloring. So in cosmetic chemistry, a chemical reaction is actually considered bad. Cosmetic chemists are constantly mixing together chemicals and are hoping that nothing happens. A chemical reaction is considered bad because it's a sign of instability and they are constantly trying to prevent that. So however, there are some cosmetic products that are specifically designed to react chemically. The most common ones are permanent waves, hair relaxers, hair bleach, and hair colors. Permanent waves are designed to change the hair of people with curly hair to straight hair by putting the hair into curlers and adding ammonium thioglycolate. Then the disulfide bonds break, and this allows the keratin molecules to move freely and form into the shape of a curl. Hair relaxers do the opposite. They change the hair of people with curly hair to straight. And a hair relaxer is like a lotion or cream that makes your hair easier to straighten and manage. So it reduces the curls by altering the texture and breaking down the hair strand. Just like permanent waves, the relaxers break down your hair's disulfide bonds and resets your kinks into a straight alignment. Now hair bleach turns brunettes into blondes. And hair colors is more complicated than bleach. So it uses hydrogen peroxide to break down the natural color. Then the peroxide also oxidizes the polymeric reaction dye monomers. So once the dye polymerizes the hair, it creates a color molecule. Anyways, let's get back to our main topic, which is makeup. And let's see what Michael has to say about surfactants.
Hello. Back again discussing surfactants. So surfactants is a substance that reduces the surface tension of a liquid in which it is dissolved. So most emulsifiers can be considered surfactants or surface active agents. An emulsifier is a substance that is a mixture of oil and water. Emulsifiers can keep oil drops packed in water. Emulsifiers are used for a fatty feel such as sun protection creams. They are used more in moisturizing products such as body lotions and day creams. And you might be curious of how emulsifiers relate to surfactants, and this is where the explanation comes in. So anionic surfactants are considered to be the go-to agents of many products that have to deal with skincare. And this group of surfactants is also the most common used among the foaming products like shampoos or body washes. And the use of these can be because primary functions are creating the high foam, high cleansing, high washing capabilities in a finished product. So that sounds really good on TV. I have the highest cleanser. So they really relate to anionic surfactants. And the most commonly used surfactant in cosmetic chemistry is sodium lauryl sulfate. And sodium lauryl sulfate is found in many laundry detergents and many shampoos and many conditioners. So it's really good for your hair. It has to do with your skin and stuff. And this can leave your skin feeling tight and smooth. Who doesn't want tight, nice, smooth, bump-free skin? Because I know I do. I do. This also relates to polarity, but I'm gonna let Leslie get to that. She'll get more into depth of what it has to do with polarity. Well, that's enough about surfactants, and if you'd like to know more, ask some questions in the comment section. I'll get back to you. Take it to Leslie.
In chemistry, polarity is a separation of electric charge leading to a molecule or its chemical groups having an electric dipole or multipole moment. So I can assume this has something to do with or intramolecular forces. Polar molecules interact through dipole, intermolecular forces, and hydrogen bonds. In making emulsions, one uses water and oil. Water is a compound. Oil, however, is a term that describes a material that is both hydrophobic and oleophilic. Oil, unlike water, is not one compound but a vast variety of compounds. The term oil includes hydrocarbons, esters, fatty alcohols, and oil-solute silicones. Oils can be solid or liquid, and unsaturation and branching will increase their liquidity. This is used in numerous makeup products that include the oil and a liquid together, from foundation to matte lipsticks. They're important materials in cosmetics formulation and often are used as emollients. One of the most interesting ways to divide oils into types is to consider polarity of the oil, nonpolar oils, and hydrocarbons. They lacked an electronegative element like oxygen, which feels why they have a hydrocarbon fuel.
This is coming to a very sad end of the first and last ending of our first and last YouTube channel. Remember, today we've learned 5 very important cosmetic chemistry facts. We learned actually more than 5, but 5 main points that we focused on. pH, balancing equations, chemical reactions, surfactants, and polarity. 5 in total. That's all for Chemist Queens. Don't forget to subscribe. And if If you have any questions, leave it in the comment section below, and hopefully we'll get back to you. Thank you.